Hello, everyone, and welcome to section 1.4, Systems of Equations. You'll see there's a little A there. That's because we're actually going to do part A and part B. 1.4 is pretty long, so I thought we would break it up into two different classes. So these first three problems are all review. You should have learned this in Algebra 1, but I thought it wouldn't hurt for us to take a few minutes to review it. A system of equations is simply a way of saying that there is more than one. So you're looking for the answer, the XY combination that works in both of the equations, and that's what's called a system, both of the equations. So you may remember something called the either elimination method or the addition method. And that is, if you add the two equations together, you can cancel one of the variables. So the 3y and the negative 3y cancel, you get 3, and then I divide both sides by 6, and I get x is equal to 1/2. So sometimes kids don't understand why that works, why we're allowed to just add two equations together. So I want to talk about that just for a second. Let's say you had 4x plus 8 is equal to 9. Then you would subtract 8 from both sides. And that makes sense to you because you know you're allowed to do the same thing to both sides. My question is, if I told you that negative 8 was equal to w, could you actually subtract 8 from one side and subtract 8w from the other? You could, because they were equal to each other. So I know that you're thinking, but why would I do that? You wouldn't do that, but you would be allowed to do it. If negative 8 and w are the same thing, you could subtract 8 from one side and subtract w from the other side, and that would be a legitimate thing. Well, in this problem, we have 4x plus 3y is equal to 2, and I want to add 2x minus 3y to this side, and I want to add 1 to this side. Why am I allowed to do that? Because 2x minus 3y is equal to 1. So you are doing the same thing to both sides. They just look different. Just like up here, you're subtracting 8 from one side and you're subtracting w from the other side. It's okay because negative 8 is equal to, negative w. Okay. Now, after you get that first variable, you do have to go back and always find the second one. So you can use either equation. I'm just going to use the top one. It doesn't actually matter. I plug the negative 1/2 in where there used to be an x. And now I can solve for y. 2 plus 3y is equal to 2. 3y is equal to 0 by subtracting 2 from both sides. Divide both sides by 3, and I get y is equal to 0. Don't stop there. There's one more step. Make sure you express your answer as an ordered pair. On the next one, I'd like to introduce something that's going to be really important to me this year, and that is clearing fractions. Clearing fractions is when you multiply through to get rid of all the fractions. People are a little intimidated by fractions, but I'm going to show you a one-step way to get rid of them. If there's just one fraction, it's easy. You multiply both sides. You always have to do things to both sides in algebra by the denominator that you see there. So I'm going to multiply both sides by 2. Don't forget that on this side, that 2 has to be distributed to both things. Proper notation is going to be very important to me. So I will use proper notation on these videos, and you need to make sure that you're copying it down correctly and then also using that same notation in your homework. So 2 times 1/2 is 1. 2 times 4 is 8. And then 2 times 4 on this side is also 8. So now this is my system, okay? Which is a much more reasonable system than the one with the 1/2 in it. People tend not to like the fractions so much. So on the last one, We added the two equations together and the y's just went away. That was a beautiful thing. That is not going to happen on a regular basis. Normally, you need to alter one of the equations to make that happen. So you have a couple choices. I'm going to multiply the bottom one by 8 on both sides, because that will give me 16x minus 8y is equal to 8. And I chose that because I was looking at that top equation, x plus 8y is equal to 8. And I thought to myself, you know what? If I multiply the bottom by 8, I'll have a negative 8y. And then when I add the two equations together, I will have the y's go away. Hopefully you remember this concept from Algebra 1 and it's coming back to you. 16 over 17. Okay? Or you could have multiplied the top one. So I'm going to just rewrite them, give you a different way of doing it. And 2x minus y is equal to 1. I'm going to give you some choices here. I could have multiplied the top one by negative 2. Now you do have to make it negative if you choose to do this, because you want them to cancel when you add them together. And then the bottom one stays the same. 2x minus y is equal to 1. And now when I do that, the x is canceled in this case. So your choices, whichever way you think of is totally fine. Divide both sides by negative 17, and I get that. Now, interestingly, if you hadn't, because we did it twice, we actually have both parts of our answer without substituting back. Some kids use this method on a regular basis. They would rather do the problem twice than take something like 16/17 and plug that back into one of the originals to find y. Plug in to find y. Some people are just like, yeah, I'd rather just do the problem twice with a number like that. That's great. So again, you're going to find that this year, now that you're getting older and you know a lot more math, you're going to have a lot more options and you'll have choices, which is really great. Another method that you might have remembered is substitution. So instead of linear combination, the substitution method is where you have one variable all by itself and you literally substitute it into the other equation, meaning you have 2x plus, and where you used to have a y, you say, well, since y is 1 plus x, I'm going to stick that 1 plus x in place of the y. That's the substitution method. That gives us 3x plus 1 is equal to negative 2. 3x is equal to negative 3. X is equal to negative 1. You still have this final step of going back and finding y. Y is equal to 1 plus x. So now I can substitute that in there. Y is equal to 1 minus 1. And I get y is equal to 0. And your final answer then would be negative 1, 0. So we just solved number 3 algebraically. Now we're going to graph both lines on the coordinate plane. This is a great chance for you to practice graphing. I would love for you to stop this video and see if you can graph both of those. But obviously, I'm going to do it right now for you. If you just keep watching all year, you're not going to do very well in this class. You really are going to want to stop the video and try it on your own. Green line first. If it really helps you, you can reverse these. So it's in the y is equal to mx plus b format. I know that if x is 0, then y is 1. That's why that's the y-intercept. And its slope is 1. So I'm going to go up 1 over 1, up 1 over 1. I tend to make the dots the entire way because that helps me draw a really nice line. If you only draw a few dots and then try and keep drawing the line and you don't stay on task, like on the line, I will take off points for that. The second line, 2x plus y is equal to negative 2. You should always get y all by itself. So I'm moving that negative 2x over. I am not, this is honors, I am not going to keep showing this step. If you need to show it, that's fine, but I won't be showing it anymore. Again, when x is 0, if I plug a 0 in there, I get negative 2. That's why that's the y-intercept is 0, negative 2. And its slope is negative 2. So from there, I can go down to over 1. Like I said, let's say that this is you and you went like that. And you got off. So this was right at, nope, wasn't even right at that point. Really, we should have gone through there. I definitely will not give you credit for that. So be thinking about that, whether or not it's worth your time to just draw the line all the way to make sure you do a great job. So the reason I wanted you to graph the lines was so that we could make the connection. When you're solving a system, you are finding the point of intersection. Let's write that down. When you are solving a system, even if you solve it algebraically, you are finding, yes, you're finding the value that works in those two equations, but you are finding also the point of intersection. Of the graphs or of the equations in the system, the graphs of the equations in the system. So we had found out algebraically that the answer was negative 1, 0, and there it is, negative 1, 0. So that's the correlation between the two things that we're doing today. Now, interestingly, I'm not going to give you any questions with a system of just two equations. That's from Algebra 1, and we're not going to do it again. Instead, today, so that was all review. Today's lesson is actually on solving a system with 3 equations in it. This is going to be not that much harder unless you're not organized. If you're organized, this is going to be a piece of cake. So pay close attention. So the first step is you're going to want to label them A, B, and C. Every one of these equations, instead of making a line, is actually making a whole plane. So you can see that there's a plane A, and a plane B, and a plane C. And somewhere those planes intersect, and we're going to find that point. And when we do, it's going to be an ordered triple instead of an ordered pair. So I look at these and I think, are there any two equations that I can put together right away and something cancels? No. So you have to always tell me what it is that you're doing. So I look down at letter C, and I think if I multiplied that one by 2, I could put it with A. So watch this. I'm going to put A down again, and I label that I'm writing A. These problems are long and hard, and I'm not going to look for your mistake if you don't label your work. So I'm going to multiply equation C by 2. That gives me 12x minus 2y plus 8z is equal to negative 6. And I chose that, again, because I wanted my y's to cancel. I could have canceled any variable, x, y, or z, but y looked the easiest to me. So that gives me 16x plus 11z is equal to 6. And I'm going to label this equation D. Now you're going to need to do this again with another 2 equations. You must use equation B because you haven't used it yet. You used A and you used C. Now you must use B. You can choose whether or not you use A again or C again for your second one, but you must use B. Now you can change B. So I look at B and I figure out which 2 I can make the easiest, but there's one more condition. You have to get rid of y again. It doesn't matter the first time if you get rid of x or y or z, but once you've committed to getting rid of y, then the second one also has to get rid of y. So just to show you that you can change both equations, I'm going to multiply b by -1. You don't have to do that, but I want to show you that that's one of your options. And now to get rid of the y, the easiest equation to use is c. And I can do it just by multiplying by 3. So again, always show me what you're doing. Write 3c. That way I know what's going in your head. I know you're thinking, oh, if I multiply c by 3, I can get rid of the y's. It tells me so much information, so make sure you do that. Times 3 is 12. Times 3 is -9. Great. So I put them together. I get 16x. The y's canceled, just like they did over here. That was good. Plus 7z is equal to -2. I'm going to call this equation E. So there's a lot of steps to this problem. Step 1, make 2 equations and get rid of a variable. Step 2, do 2 more equations, get rid of the same variable, use one of the other equations. Step 3, put D and E together and get rid of another variable. Now this one's pretty obvious. I'm going to get rid of the x by multiplying D by -1. So -16x minus 11z is equal to -6. And equation E I don't need to change because the 16s will cancel. Plus 7z is equal to -2. And that gives me -4z is equal to -8. Divide both sides by -4, and I get z is equal to 2. Now that I know that z is equal to 2, I'm going to go back just one step to equation D or E to find another variable. I'm going to go back to equation D or E to find another variable, in this case x, by plugging in z is equal to 2. So they both look good. It doesn't really matter which one you pick. So I'm going to do 16x plus 7. I'm choosing E. 7 times 2 is equal to -2. 16x plus 14 is equal to -2. 16x is equal to -16. X is equal to -1. So I'm getting there. I've got 2 of my variables. Final step. Last step. Plug the 2 variables that you know, or that you've found, into any of the 3 original equations to find the last variable. So if we were in school, I'd let somebody pick, but now I have to pick. So I'm going to scroll back up here. Can I see them at the same time? No, but I have a piece of paper with me. So I'm going to just pick one. It doesn't really matter. I'm going to pick A. And I have 4 times -1 plus 2 times y. Y is the variable I still don't know. Plus 3 times 2 is equal to 12. -4 plus 2y plus 6 is equal to 12. 2y plus 2 is equal to 12. 2y is equal to 10. Y is equal to 5. So now I'm going to take those answers. Y is 5, and z is 2, and x is -1, And I'm going to bring them all together. If you stop there, you're still not done. Ordered triple is always x, then y, then z. So x, then y, then z. Now, you'll be so exhausted by this time that I don't think you're actually going to check your work. But if you did want to check your work, then these three numbers should work in equations A, B, and C. If it works in all three of them, you can literally walk away 100% confident that you did it right. But obviously, the easiest thing to do is just open the back of your book and see if you got it right. So you'll notice in your notes that I only did one of these examples before jumping into a word problem. There's nothing else to teach you. You just need to practice it. This is a long, complicated thing. So you have some homework on it, systems of three equations. Rewatch this section if you need to, but these are the steps. The key, make your paper neat. If you're able to work in a neat and orderly way, then this section will go really well for you. Word problems. An amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in section B as in section A. And if they sell all 23,000 seats, they make $870,000. So the question is, how many seats are in each section? So if you don't want to actually count, but you knew this information, then you could figure it out. So let's have let's stay with x. X is equal to the number of seats in A. Y will be the number of seats in B. And Z will be the number of lawn seats. Always make sure that you define your variables. You can't assume that I know it. And then you can make your system. So you know how much they charge, which means if you take all the seats in X and you multiply it by 75, that'll give you how much money you made for all the seats in X. If you add that to how much money you make for all the seats in section B, and you add that to how much money you make for all the seats in the lawn area, which we're calling number of seats Z, then the total amount of money they make is $870,000. So just as an example, so if they sold 100 section A seats, then 100 times 75 would give you the revenue from that one section. Now, how many seats are there? Well, if you take all the X seats and all the Y seats and all the Z seats, there are 23,000 seats. Now you need 3 equations to solve for 3 unknowns. If you have 2 equations and 2 unknowns, that works, 1 equation and 1 unknown. But if you have 3 unknowns, you need 3 equations. So somewhere hidden in the problem, there's another one. It's right here. There are 3 times as many seats in section B as in section A. I'm going to put a little star here and write that this is most missed. I'm telling you right now, this question is either on a quiz or the test. Not this exact question, but this concept. And this is highly missed every year. So the biggest problem is that kids don't know which way it goes. They don't know if it's supposed to be 3x is equal to y or 3y is equal to x. I will just tell you, test a point. That's the way you got to do it. Test a point. So if x is 10 seats, then according to this formula, y would be 30 seats, right? On this way, if y was 10 seats, then x would be 30 seats. You see what I'm saying? So this one, just if you made x 10, then y would be 30. But on this one, if you made y 10, x would be 30. So since x represents A and y represents B, which way do you want it? There are 3 times as many seats in B. Which one of these has 3 times as many in B? The top one. That's the one that you want. But people read this and they go, there are 3 times as many seats in B as in A. And they get it wrong. Okay? You have to actually think about how it works. It's not that way. It's actually 3x is equal to y, which actually should make sense. If you took the number of seats in A and multiplied it by 3, you would get how many seats there are in section B, because there are 3 times as many. So on this problem, unlike the one that we just did, which was much more formal and there were lots of really hard equations, this one's actually a little bit easier because you can use substitution to get rid of one variable right away. So I look at this one and I say, oh, I can replace the y with 3x. So you can still call them equations A, B, and C if you want to, but it's not quite as important in here when you're going to use substitution. That method is really best for when you're trying to show me what you're doing to each equation. In this case, substitution is probably the better method. So let's write that down. Use substitution. Oh, that really doesn't want to write today. Sorry about that. Use substitution. Now, if you did label them A, B, C, then you could write, you're going to put C into A. So x plus 3x plus z is equal to 23,000, which then goes to 4x plus z is equal to 23,000. And then I'm going to put c into, oh, I wrote c into a on that one. C into b. And then I am going to put c into a. So 75x plus 55, so I'm going to replace that y with 3x times 3x plus z, oh no, plus 30z, plus 30z is equal to 870,000. And you are going to want to simplify that a little bit. So 55 times 3 is 165, 75x plus 165x plus 30z is equal to 870,000. And that 165 plus the 75 is 240. So now I have 240x plus 160, no, sorry, already got that, plus 30z is equal to $870,000. So look what happened. By using substitution, I still made the same goal. It's kind of like I have an equation D and an equation E, if you want to think about it that way. My goal was still to get 3 variables down to just 2 and the same 2. They always need to be the same 2. If you have this one with x's and y's and this one with y's and z's, you're still not going to be able to do anything. So now I'm going to take equation D and E and do something. So the easiest thing is to multiply D by negative 30. So negative 30D gives me negative 120x minus 30z, and then 23,000 times negative 30 is negative 690,000. And on this one, I'm not going to do anything to equation E. I'm just going to leave it. 240x plus 30z is equal to 870,000. These are big numbers. This is real life now. So the z's cancel, and this becomes 120x is equal to, let me do this math here real quick, equals 180,000. Divide both sides by 120, and x is equal to 1,500. That's how many seats are in section A. So even though I didn't use combination, I used substitution instead, I still had the same goal of getting an equation D and E, putting D and E together, getting one of the variables. And now the process is also the same. So let's just go back to this page so that you can see it. Once we got D and E, what did we do? We go back to D or E to find another variable by plugging in whatever you got. So in this case, I got the 180, not the 180, the 1,500, and I'm going to plug it back into D or E. So I choose D. D is definitely easier. D. 4 times 1,500 plus Z is equal to 23,000. So 4 times 1,500 is 6,000 plus Z is equal to 23,000. 23,000 minus 6,000, Z is equal to 17,000. Now I have my second answer. And what is the final step? Hopefully you were taking good notes the first time. This is how your homework's going to go too. If you don't take good notes, you won't be able to look back. Last step, plug the variables that you found into any of the original equations to find the last variable. So if you take good notes in this class, you'll find that you can really go back and use them. It'll make your life much better. So here's our second one. So now I'm going to go back to any of my original equations. So interestingly, I'm actually going to go back to equation C. Equation C is easiest. Easiest. That was terrible. I have to rewrite that. Equation C is easiest. Look at that one. 3 times x is equal to y. 4,500 is equal to y. Now, you are not going to write this as an ordered triple. Instead, you're going to answer the question as a word problem. If somebody walked up to you and said, how many seats are in each section? And you said 1,500, 4,500, 17,000, that's not an answer. You would say, there are 1,500 seats in section A, 4,500 in section B, and 17,000 lawn seats. That's how you answer a question like this. And I will not give you full credit for 1,500, 4,500, 17,000. Okay? When it's a word problem, you answer in a sentence. So if you guys were in school, I would stop teaching and I would send you off into your groups and I would ask you to do these equations. So I can't stress enough that the best way for you to get through this class is for you to try this one on your own. Maybe you've already set up a little bit of a math group with somebody else in your class and you can be talking these out together. Talking them out is really great, not just trying them on your own and then looking at the answer. So I can't encourage you enough to do that, but this video will continue because I will show you how to do that. So Sam's Furniture Stores places the following advertisement in the local newspaper. Write a system of equations for the 3 combinations of furniture. what is the price of each piece of furniture? So when you're trying to define your variables, the last sentence often gives you a great way to define them. What is the price for each piece of furniture? So X is the price of the sofa. See how it's actually answering the question? X is the price of the sofa. Y is the price. It can be any of them. I could do chair or love seat, but I feel like I'm just getting smaller. Of the love seat. And Z is the price of the chair. And then when you answer at the end, you would say, the sofa is $1,200. The love seat is $800. The chair is whatever. Okay. I am actually going to write the answers over here in case you did do it on your own, which makes me so happy. So the sofa is $800 and the love seat is $500 and the chair is $300. Okay, so if you did this on your own, I'm so proud of you. Okay, so let's write our equations. It says the sofa, which we called X, plus the love seat, which is Y, is equal to $1,300. If you buy the sofa, X, and you buy 2 chairs, 2Z, then that is going to be $1,400. Or maybe you buy a sofa, a love seat, and 1 chair. That would cost you $1,600. So how much are they individually? You can solve this system of equations. Remember, you're always starting with 3, and your goal is to get a system that only has 2 variables in it. So here's an interesting fact. This one only has 2, and this one only has 2, but you see how you couldn't solve those together because between them they have 3. So what I'm going to do is I'm going to use A, which is X plus Y, is equal to 1,300. And I'm going to do negative C. If I do negative C minus X minus Y minus Z is equal to minus 1,600. My goal was to get rid of the Y's because I thought, oh, if I get rid of the 2 Y's, then I can put it with B, which is also missing a Y. But ironically, I'm going to go do it. And look, not only the X is canceled, but the Y's also canceled. It's like winning the lottery. With a single step, I actually just found the cost of a chair, $300. So you can't let this throw you. You can't need every single problem to be identical. This one, a good thing happened, and that actually makes it easier, not harder. But still think about what your goal is. Now that you know Z, look back at your 3 equations. Does that help you solve any of them? Well, it doesn't help you solve C because you still have X and Y. Z is not even in A, but you can plug it into B. So this is not on our little pattern, but you can do this. X plus 2 times 300 is equal to 1,400. X plus 600 is equal to 1,400. X is equal to 800. Now I know the cost of the sofa. And the last step is the same. I have 2 of the variables. I need the 3rd one. So I actually have choices. I could pick equation C and plug in both Z and X and find Y. Or I could just plug X into A. So using A, I don't have to do it this way, but it's a little bit shorter. Using A, 800 plus Y is equal to 1,300. Y is equal to 500. Again, don't stop there. Make sure you write out your answer. The sofa is $800. The love seat is $500. And the chair is $300. Don't be lazy on that last step. Make sure you write it out. So I really like this problem because it shows you how diverse it can be. Number 3. If you did it on your own, here are the answers. 7 first place finishers. There were 10 second place. And that's a 10, not an 8. And there were 3 third place. So I would love for you to do this on your own. But if you can't, that's okay. You're going to have lots of homework to do on your own. You can keep watching. So Lawrence High prevailed in Saturday's track meet with the help of 20 individual event place earners, earning a combined 68 points. A first place finish earns 5 points. A second place finish earns 3 points. And a third place finish earns 1 point. Lawrence had a strong second place showing with as many second place finishers as first and third place finishers combined. So one equation is usually just the total. So you had 20 individual event placers. So I was going to say x plus y plus z is equal to 20. But then I just realized I didn't actually tell you what x plus y and z all meant. Always define your variable. So x is the number of first place finishers. Y is the number of second place finishers. And Z is the number of third place. Now I know it's really tempting not to write all that. It's tempting to write X is first place, Y, not even place. Y is second, Z is third. While that is great if you're doing something for you personally, it doesn't help somebody else know what you're doing. Somebody else couldn't look at your paper. They could decipher it maybe, but it's not obvious to them because X isn't first place. X is a number. It's the number of first place finishers. So don't be lazy. You're in honors. So the combined points was 68. So I can see that that's also going to be an equation. Each first place finisher got 5 points. Each second place finisher got 3 points. And each third place finisher got 1 point. So if you take all the points earned by first, second, and third place finishers, they had a combined earning of 68. But 2 equations isn't enough to solve 3 unknowns, so they had to give you another piece of information. And it's in this last sentence. Lawrence had a strong second place showing with as many second place as first and third place finishers combined. So this number of kids was the same as how many kids finished first and how many kids finished third. So there you go. Now you have your 3 equations. So interestingly, this is really close to being set up in the traditional way, where you have A, and then you have B, 5x plus 3y plus z is equal to 68. And then you could even alter this so that it looked just like the others. X minus y plus z is equal to 0, meaning I could subtract y from both sides, and then I have 3 nice normal looking equations. And then you could use the system that we used before where you start with 2 equations and then 2 more and you put it all together. Some people really like that. Or, okay, you can do it more traditionally, or you can use substitution. Some people like that. So they think of this as A still, and this is B, and this is C, and you can put C into A. That would give you X plus, and instead of Y, I'm going to write X plus Z is equal to 20. And that becomes 2X plus 2Z is equal to 20. And then you could put C into B. So you have 5X plus 3, and instead of Y, I can put in X plus Z is equal to 68. That gives me 5X plus 3X plus 3Z plus Z is equal to 68, which gives me 8X plus 4Z is equal to 68. And now I have equation D and I have equation E. That's one choice, and you can finish it from there. The other choice, like I said, is to do it over here on this black method, where maybe you put A and C together, because it's easy. You might be looking at that and saying, oh, I'm just going to put A and C together. Look how nice this is. And this is why usually the kids are doing this on their own, and I'm just walking around giving you little hints, because it's fun to see all the different ways that people try and do it. You can call that D. And then you could put, now we have to get rid of Y again. So, and you have to use B. So I'm going to use B, and I'm going to use 3C. So B is 5X plus 3Y plus Z is equal to 68. And 3C would give me 3X minus 3Y minus 3Z is equal to 0. 0 times 3 is still 0. Oh, actually, this is plus. And that would give me 8X plus 4Z is equal to 68. Do you guys see what happened? I got the same D and E as I did over here. It's just amazing. So I'm actually not going to finish this one. I'm going to let you finish it, because I want to see if you can get that last step. You're going to take D and E and put them together. So go ahead and try that. I know some of you are not pausing. You're just waiting for me to do it, aren't you? Oh, you're so bad. I would really love to see you guys try and put them together. All right. I'm going to actually show you an interesting concept. Instead of putting these together and trying to get something to cancel, I'm actually going to reduce D. I'm going to divide D by 2. That gives me X plus Z is equal to 10. And I'm going to take Z, or E, and I'm going to divide E by 4. Just like over here, we multiplied C by 3. I'm going to divide it. I think that might make my life easier. 2X plus Z is equal to, and then 68 divided by 4 is 17. And that to me looks so much easier than working with D and E. And now I'm going to put a negative on one of them. So negative, negative, and negative. And that gives me X, the Z's cancel, is equal to 7. So I just found the number of first placed finishers. How do I go back? Well, I could go back to E, or I could go back to D. I like D better. Plug into D. But E is a perfectly good choice. So 2 times 14 plus 2Z is equal to 20. You actually could have gone back even to D over 2. So 28 plus 2z is equal to 20. I have 2z is equal to negative 8. What did I do wrong here? Oh, I was already getting to the 14 in my head. 2 times 7, which is going to be 14, because you can't have a negative number of place finishers. So is equal to 6, z is equal to 3. Now I know how many third place finishers there was, and then I take the 2 that I know so far, and I can put them back into A, B, or C. Any of those equations will do. Well, since I know that there were 20 altogether, I'm going to use A. There were 7 plus some second place finishers plus the third place finishers. I know it added up to 20, so y is equal to 10. Remember to write your answer as a sentence. There were 7 first place finishers. I know this is annoying, but we're going to make you great. 10 second place. I don't mind if you write it that way. Second place finishers. And 3 third place finishers. Great. I hope you did some of that on your own. Next one. So you do need a little bit of geometry here. Hopefully you remember that the sum of the degrees of the angles in a triangle is 180 degrees. So what you need to know from that is the first equation. The measure of angle A plus the measure of angle B plus the measure of angle C will equal 180 degrees. So if you didn't know that, you would never get equation number 1. Now, for our purposes, I know I keep telling you to label everything, but you're welcome to leave the degrees out just to make your life easier. And then they told you that angle C is equal to A plus B. And they told you that angle B is equal to 5 times angle A minus C. So now you can choose what method you want to use, but I would not call them equations A, B, and C. You can call them equations 1, 2, and 3 if you would like to, or X, Y, Z, but you can't call them A, B, and C since that's already in there. So let's see. Sometimes you might have to look at it for a minute and think, what's the easiest thing to do? So I think I'm going to use a little bit of substitution and a little bit of combination. I'm going to rewrite this as I'm going to put 3 into 1. So I'm going to write it as A plus, I'm going to replace B, because that's why I'm putting 3 into 1, 5A minus C plus C is equal to 180. And I'm going to convert this one a little bit. I'm going to change this to A plus B minus C is equal to 0. I like that better. And then I'm going to do the same thing. I'm going to put 3 into 2. So this is going to be A. And again, instead of B, I'm going to do 5A minus C is equal to 0. That gives me 6A is equal to 180. And this gives me 6A minus 2C is equal to 0. So I was expecting to have an equation with A's and C's, and then I was going to cancel the A or the C. But it turns out that I got lucky again. This one I can solve right away. I don't need to always follow the same pattern. A is equal to 30. Divide both sides by 6. And now I can put these two together. So 6 times 30 minus 2C is equal to 0. 180 minus 2C is equal to 0. 180 is equal to 2c. C is equal to 90. The last step is almost always the same. You want to take the two that you know so far and put them back into one of the originals. So I'm going to take my A is 30 and my C is 90. And I personally am going to choose equation 3. You can choose any of them. So B is 5 times A minus C. So B is 150, oops, 150 minus 90, so B is 60. Now, this isn't really a word problem. It's just asking for what are the measures of angles A, B, and C. So angle A is 30 degrees. Make sure you use your degree symbol. Angle B is 60 degrees. And angle C is 90 degrees. And always box your final answer. You guys are hanging in there. This is a long section. So there are some extension questions. They're mostly thinking ones. Boy, you're going to get sick of me saying this, but I would love for you not to just watch this video. I would love for you to stop and think. Class is very different this year, but if you don't try and follow that concept, you won't do as well as we've done in other years, because you need to be thinking on your own, not just writing down everything I say. Determine whether the system of equations that represents the circle has no solution, one solution, or infinitely many. Remember way back at the beginning of this very long video, I said that the solution to a system represents the points of intersection. So since these three don't intersect anywhere, there is no solution. And mathematicians came up with a way to write no solution. It's a 0 with a slash through it. So if you write that, that means no solution. Now, A is a little trickier. Sometimes people think that this is a solution and this and this and this, but that's actually not true. It means that this one is only a solution for those two circles, and this one's only a solution for those two circles. The only one that's a solution for all three is that middle one. So this one has exactly one solution. Last one. Find the values of A, B, and C so that the linear system has -1, 2, and -3 as its solution. So what does it mean to be a solution? It means that when I plug this ordered triple in, it makes the equation true. So I can find A by plugging it in. -1 plus 2 times 2 minus 3 times -3. That should give me A. So -1 plus 4 plus 9 is equal to A. A is equal to 12. Go ahead and see if you can do that for B and C. So remember, a solution is an ordered triple that makes the equation true. So if you want this to be true, then C would have to be 10. A would have to be 12. And B would have to be -4. Those are the three answers. Don't forget, there's instructions on how I want the homework done. It's a little bit nitpicky, but remember, I am making you great mathematicians. Next class, we'll be doing the very last section of this chapter. So we'll be finishing up section 1.4, and then we will be done the whole chapter. All right. Have a great day, everyone.